In section 4.5, we're going to talk about different ways of counting things, and we need to be really careful to read our problems and make sure that we're understanding the problems, because how we're going to approach each one is slightly different. However, we can use our formula to do our calculators to do a lot of the formulas and the heavy lifting for us. That can save us a lot of time and energy, and then we can just focus on making sure we understand the concepts. So the first thing that we're going to talk about is the fundamental counting rule or principle. And the fundamental counting rule or principle says that if you're worried about how two different things can occur, then what you're going to do is find the number of ways the first thing can occur and the number of ways the second thing can occur. And then to find out how the two events can occur one after the other, we're just going to multiply them. So it'll take the number of ways that the first item can happen times the number of ways the second item can happen, and that will be, once you get that value, the number of ways that then one after another can happen. So this is going to get used a lot, and in the actual formula or rule, we only mention 2 items, but this can be generalized to 5, 10, any number you want. A great example is license plates. License plates have to be in where you're doing one thing after another, and you can talk about the different ways or choices that you have for each and every element. So when I think of fundamental counting rule or principle, I think of us looking at different slots that we're trying to fill in a specific order. So this license plate one is perfect. We have 6 things on our license plates. We have 1, 2, 3 letters first. I'm going to put L for letter underneath. And then we're going to have 3 digits or numbers afterwards. So 1, 2, 3 more slots with, those have to be numbers or digits. So let's talk about the letters first. Well, they say we need to find out how many ways there are to do those things first. Well, there are how many letters in the alphabet? 26. So for my first slot that has to be a letter, I have 26 choices. Okay. Well, what's cool about license plates is you can repeat the same letter. So the next one, it's understood that this is with replacement because I can reuse the letter, I can repeat myself. There are now still 26 letters for my second letter to choose from. And for my third letter, same thing, I can repeat myself again. I could have A as my license plate beginning. That's absolutely fine, so I still have all 26 letters to choose from. Now what comes next are my 3 numbers, my 3 digits. Be careful. How many numbers do you have to choose from? We have 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. That is actually a total of 10 numbers to actually choose from. So I've got 10 choices for my first number. And again, I can still repeat myself. So I've got another 10 I can still choose from for my second number. And I've still got 10 to choose from for my third number. And remember, fundamental counting rule or principle said, let's multiply all this, kind of like the AND rule did for finding probabilities. So we're doing 26 times 26 times 26 times 10 times 10 times 10. We're going to end up with a very large number possibly. So 26 times 26 times 26 times 10 times 10 times 10 gives me something huge. It's 17,576,000. And that's how many license plates are possible if you just have 3 letters and 3 numbers. Now, of course, this doesn't take into account there are certain words that you don't spell and certain number combinations you don't want to use. But this just gives you a rough idea of how many license plates are possible. And that is a huge number. Here's another one. The access code for a security system uses 4 digits. Each digit can be 0 through 9. How many codes are possible? So the idea is we've got 4 slots. This time we're only looking at numbers. This would be also very similar to if you were doing a PIN code for an ATM. So, and they want us to do this 2 different ways. Okay, what if you can't repeat digits? Well, and what if you can repeat digits? So no digits can be repeated. Well, for your first number, you could choose any of the numbers 0 through 9, which would tell you that you've got a total of 10. However, if they tell me I can't repeat myself once you've used one, it's gone. It's kind of like the without replacement with cards. Once you choose a number, it's gone, it's dead, you can't use it again. So for my second number, I'd only have 9 to choose from. Now you have 2 numbers you can't choose. So for my third number, I'd only have 8 numbers to choose from. Continuing right along, I'd work my way down to only having 7 numbers to choose from. So I do my 10 times 9 times 7, 10 times 9 times 8 times 7, which would give me a total of 5,040 possibilities for my code. And that's if I'm not allowing myself to repeat. However, if I do allow myself to repeat like I have on B, I'd have 10 choices for my first number, and I'd still have 10 for my second, all 10s to still choose from for my third, and all 10 to choose from for my fourth, which is basically, when I multiply those together, a 10 to the fourth, which is going to give me 10,000. So notice, just by not allowing repetition, the number of possibilities pretty much got cut in half. That is a huge difference. This also means, though, you have how many different possibilities for an ATM code? 10,000. And that's if you're just using numbers and only a 4-digit combination. So, is anybody guessing your ATM code randomly? Nope. Chances are they're not, because there's 10,000 possibilities. It's because they figured it out, or somehow they knew part of your code anyways. Very interesting. Let's take a look at a new symbol. This new symbol, this exclamation mark, it looks like one, is called a factorial symbol. And what it would look like is something like 3 with the factorial symbol behind it. So what that is read as is 3 factorial. And what 3 factorial means is that you'll start at 3 and multiply every number below it until you hit 1. So it'd be 3 times 2 times 1, which is going to give you 6. So another example would be, we've got it right here in the middle of the page, is 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. The question is, when would we use this factorial? Well, we would use it in, for example, something like the next problem. Find the number of different ways 9 players on a baseball team can line up for the national anthem. And the reason why is we're going to make a lineup of all 9 baseball players. 1, 2, 3, 4, 5, 6, 7, 8, 9 baseball players. And for your first place in line, you can choose from all 9. But once somebody's in your first place in line, then for your second place, you only have 8, then 7, then 6, then 5, then 4, then 3, then 2, then 1. So it's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which just happens to be the same thing as a 9 factorial, which can be done on your calculator. There's another video on how to use your calculator using permutations. So what you can do is type in the 9 factorial into your calculator and you will get the following value. So when we multiply these all together and we get our factorial, we get 362,880. That's a very large number, but that's the number of different ways you can create a lineup of 9 players.